Hello everyone. Today we're looking at the problem assign elements to groups with constraints, which was question 2 in weekly contest 436. So the question reads that we are given an integer array groups, where groups I represents the size of that group. We're also given an integer array called elements. And what we want to do is assign one element to each group based on the following rules. So an element j can be assigned to group I if groups I is divisible by elements j. If there are multiple ones that are divisible, we want to pick the first one that occurs with the smallest index j. And then if no element satisfies the condition, we assign -1. So we want to return an integer array assigned, where assigned I is the index of the element chosen for each group, or -1 if no element exists. So looking at the example where groups is 8, 4, 3, 2, 4, and elements is 4, 2, we would return 0, 0, -1, 1, 0. And the reason is that we can assign this element 4 to 8, 4, and 4 here. So that means this element at index 0 will show up here, 0, 0, 0. For this group 3, there's nothing in elements divisible that divides by 3. So what we would do is just put -1 here. Then what we would do is that for this element here, we'll see that the first element in elements that's divisible is 2. So we would put that index 1 in this spot. So really what we're doing is we're going to find the first element that divides the group and use that index. So a naive approach here might be to do this in an n squared way. So what would that look like? Well, say we're looking at this group right here. We could say, okay, I have this 8. Let's iterate through my elements until I find one that is divisible that divides this 8, right? So I would find this 4. Okay, then I can move on. The same for 4. We would iterate through elements, find 4. Okay, then go to 3, iterate, so on and so forth. So really what we would do is for each group, we would have to go through every single element. But this can be of size n, and this can be of size n. So this would be n squared, right? And this would be too slow. We could do better than this. So what we want to do is use a concept called a sieve. And if you use the sieve of Eratosthenes for prime numbers, this is a pretty similar concept, but we're going to use it in a slightly different way. And what this allows us to do is basically look for each group and find the first element that divides it in constant time. So what does this look like? Let's just use a smaller example. Let's say we have 10 elements in here. So I'm going to start this with all -1s. And this is basically saying that for, say, element 0, element 1, element 2, or rather value 0, 1, and 2, I have not found any value that divides it yet. So what I can do now is say, let's go through all of my elements. And what I'm going to do is I'm going to update my sieve for each place that this element divides it. So I would start with my element 4 here. What I would do is say, okay, let's look at this position 4. And so far we haven't found anything that divides this number. So let's get rid of this -1 and put 0. And this means that we have found at element 0 that that element divides a number of this size. So then we want to do all the multiples of 4 as well. Because, for example, if we have a 4, we know that it divides 4 and it divides 8 here. So we would also do all of the multiples up to the end of our sieve. Just to recap what we're doing here, basically we're taking this 4 and we're going to mark 4 and all of its multiples and say the first place that I find an element that divides this is at index 0. Similarly, for 2, we're going to do the same thing. So here we're going to come to 2 and say, we have not found anything that divides this yet. So let's say, I'm now going to say 1. At element 1, this is the first time I found a number that can divide this cleanly. So now let's move over to 4. Remember, we have to do all the multiples of 2. So should we update this? Well, we shouldn't, because we want this sieve to tell us the first place we find a number that is divisible. So we've already found one at 0, right? We're saying at element 0, we can divide this 4. So even though technically 2 can as well, we'll see that we've already found a number here, so we don't want to update it. Then we'll come over to 6. Here we'll say, okay, we haven't found any element to divide 6, so here we can update 1 as well. Then we come over to 8. And here again, we've already found an element that can divide 8. So we don't want to update here. So now that we've gone through all our elements, we found essentially the first element that can divide all these numbers. So how do we actually use this? So let's have our answer array here. Then what we can do is we can go through our groups and say, okay, so let's look at 8. So we'll come to 8 and say, the first element that can divide me is 0. So I'll put 0 here. Then I'll come to 4. The first element that can divide me is 0. So I'll put 0 here. Then I'll come to 3. So 3 is -1, and this means that we have not found any element that can divide this cleanly. So what we're going to do is just put that -1 here. Then we come to 2. And at 2, we have this 1 value. So we put 1 here. Then we come to 4 again. And again, we have 0. So this array right here would be our final answer. So what we did here is rather than having to go through all the elements for each group, we're going to do some pre-processing and make the sieve, and then we can answer each of these queries in constant time by just looking at that index and getting whatever value is there. So the first thing we do here is set up our sieve. We're going to start our sieve with all -1s, and the size of it's going to be 10 to the 5 plus 1. So the possible values here in this problem can go up to 10 to the 5. We just add that 1 to account for our indexing. Then what we want to do is we want to actually fill our sieve with values. So this first check we do handles duplicate values in our elements. So say previously we already processed 4, right? We had 4 as one of our elements. We went through 4 and all its multiples and updated our sieve. If we see this, we don't want to do that work again, right? Because this means that we previously saw the same value, so we don't want to generate all the possible values for it again, so we just continue past. Then this case is where this is an element that we have not seen before. So what we want to do here is we want to go through that element and all its multiples and update any potential answers there. So essentially what we do is we check that location in our sieve and we say if we've already found a value there, we don't want to do anything. But if not, we want to update that sieve index there with our element index, right? And this is basically saying that if we look at this value in our sieve, it will give us the first element or first index in elements that satisfies that condition. Then after that, we want to generate our answer. So what we do is very simple. We're just going to iterate through all our groups, and we're going to get whatever value we have in our sieve for that group value. Then at the end, we just return our answer. So let's submit and make sure that it works. And it does work. Hopefully this is helpful and it made sense. If you liked the video, please like and subscribe, and thank you for watching.